Okay, we now want to prove that this is a big deal, that the null space of a linear transformation is a subspace of the domain, right? First place, you want a little notation. Now you told me, I said, what's a null space? You said, well, it's a set of all vectors mapped as a zero vector. Perfect. Then you said that right away, so that's really good. But let's see how that translates into a notation that we can believe. Okay, well, you have a linear transformation. It's going to really help in writing out the proof if we've got something to call that transformation. What do you want to call the transformation?
T.
T. Okay? So we call it anything. Let T be the transformation. What else do we need?
We need an equation, a set of vectors.
Yeah, we can't have an equation, do I have something else? So we've got to have a domain. What do you want to use for the domain?
R3.
Huh?
R3.
You can't be specific. We never said this was a transformation of a real Euclidean space, did we?
We could just say D then.
I think maybe we want to call it V.
Okay.
Okay? And just for the heck of it, we're probably going to want to talk about vectors in W, like that's where the zero vector is, right? Because we're going from the V to the zero vector of W, okay? So there are reasons we want to write this out, not just have it, not just because that's how you always see it. We have to have these names to refer to. Now, when you're writing out a proof, leave yourself some space because you're probably going to forget something up here, okay? Right? But maybe I didn't forget anything, so I'm just going to risk it and not lose any space, not leave any space, okay? So, null space. How would I express null space in set notation? Well, I'm just going to write it out. It's a set of vectors V T of V equals 0, okay? I could write that out in words, okay? I could say, well, the null space would be the set of vectors V such that T of V equals the zero vector of W. I didn't even mention W in this, but, officially maybe I should have. There's, you always have to consider what absolutely needs to be said in the context at the level you're talking about and what doesn't. You don't want to say too much, but you do have to know what is implicitly understood before you can get away with not saying something. So I'm saying it's implicit that we understand that 0 is in W, even though I know it probably isn't. Okay? You should probably say it. I didn't have room to write it, so I didn't. Okay, so the null space is this, right? So, what do we have to prove? Prove closure. Under addition. So write out for me how you would go about beginning to prove that, or write out the whole proof. I think you could probably do it, but let's see what you can do here.